Thank you very much, and good morning to everyone again. Before I go into the scopes for the high temperature gas reactor area, I am going to discuss our high temperature gas reactor program and just some of the activities we have been focusing on. So within our high temperature gas reactor program, we are generally focused in 4 different areas to help reduce technical risk and barriers to allow deployment of a high temperature gas reactor. And these focus areas really have been areas we've worked on for a while now, especially for TRISO fuel fabrication and for and qualification and graphite qualification. These 2 areas were considered high priority items dating back to the Energy Policy Act of 2005, when the Next Generation Nuclear Plant Program requested development of a high temperature reactor that could provide not only electricity, but also produce hydrogen. So at that time, it was determined that a high temperature gas reactor could meet those needs, and that TRISO fuel and graphite would be necessary for that type of design. And while we haven't moved forward with the next generation nuclear plant, we are still working on TRISO fuel and graphite qualification because that was determined to be, again, very high priority, long-term pull in the tent that could really address many technical challenges for many designs. 2 other areas of the 4 that we are generally focused on within our high temperature gas reactor program are for design and safety method development, and that includes experimental validation, and I'll go into the detail a little more on in a few slides. And also high temperature alloy characterization testing and codification. And within this area, I really want to highlight something that I think we're all very proud of. Just about a year ago, through support of this program, Alloy 617 was added to the ASME Section 3 Division 5 code, allowing Alloy 617 to be used in high temperature reactors. And this is the first alloy added in over 30 years, and before there was only 5 materials, and now alloy 617 makes 6. And so that's a very big accomplishment that I'm really glad that our experts have worked on. So that will hopefully help industry and make another material available for use. So I'm going to go into a little more detail in our other 3 areas as well. Within our TRISO fuel qualification efforts, we have developed 7 different experiments within our Advanced Gas Reactor HTGR program. We started off with HTGR1, which really was our lab scale effort to show that we could make TRISO fuel in a methodical manner. Then we had HTGR2, which is our engineering scale experiment, which also included production of uranium oxycarbide as well as uranium dioxide bearing TRISO fuel kernels within our TRISO fuel. Then we had our HTGR3 and 4 experiments, which really provides the bulk of our fission product transport and source term data, and also include design to fail fuel. And finally, we had our HTGR5, 6, 7 experiments, which we have just recently completed irradiation of. And this is acting as one of our capstone experiments, really, to provide the bulk of the remaining fuel qualification data and to help us quantify fuel performance margin. So all these different experiments now have completed irradiation. Some of the data is available already. We included HTGR1 and 2 data in a topical report in collaboration with EPRI recently. And we are now working on post-irradiation examination of our last experiment, and all this data is being captured and then will be made available to industry in the future. Then within graphite qualification efforts, we also had several experiments developed through this program with our Advanced Graphite Creep, or AGC, experiments. There were 4 different experiments that were irradiated, and we have begun post-irradiation examination of our AGC4 experiment. We are also in the process of irradiating one of 2 high-dose graphite experiments. High-dose graphite 1 experiment has begun irradiation, and we will continue irradiation when the advanced test reactor is available again. And these high-dose graphite experiments reinsert some of the graphite specimens that were in the AGC experiments, as well as inserting several fine-grained graphite grades that are of interest to molten salt reactors. And we will be exposing these graphite specimens to higher dose, which is more closely tied to the dose that's seen in pebble bed reactors. So this is all to support eventually qualifying different grades of graphite for use, so that different developers can have that risk reduced for using this graphite. And then I mentioned before that within our computational methods and experimental validation area, we have performed actual experimental validation through development of several different integral effects test facilities. Two examples here are our Natural Convection Shutdown Heat Removal Test Facility, or NSTF, which is located at Argonne National Laboratory. And then we also had the High Temperature Test Facility, which was built at Oregon State University. And these facilities have allowed us to observe thermal-hydraulic response during normal and anticipated transients. And really, that data then has been used to then enhance and improve our computational methods. So this slide is just a few of the developers and designs that are currently being developed within the US. It's definitely not all encompassing, but I just wanted to highlight again that there are so many different possible high temperature gas reactor designs, and they range from very small and transportable like a microreactor to large, more like conventional current light water reactors, but using high temperature gas reactor technology. And they can use solid core prismatic fuel forms, or they can use pebble bed reactor forms. And we are trying to support all these different types of designs within our program. Okay, so now that brings me to the first of our NEOP calls. First one is under RC2. I think that's actually supposed to be RC4. I apologize. This is for our high temperature gas reactor pebble fuel testing development. Currently, there are no approved test standards available for pebbles, and there are several developers who are looking into pebble-based fuel. So we're seeking proposals that could provide some input onto what a comprehensive test methodology would look like. So some areas of interest for proposals including looking into literature reviews to determine what has been done in the past and what current testing practices are. We're interested in modeling various test practices, and really we're looking also into different testing programs to validate different test methods. And in the end, we'd like to see some test protocol for mechanical, chemical, and wear testing of fuel pebbles. And we left it very high level in our description because we do want to see input from the different primary investigators and your teams on what you think is necessary. You can give us the details in your pre-applications and your proposals. For this call, the federal point of contact will be my colleague, Dylan Prévost, and the technical point of contact will be Will Wines, who is our technical lead for graphite qualification within the high temperature gas reactor program. So very much looking forward to seeing what you will propose. Again, please read the full set of details within the funding opportunity announcement.